In this lesson, we are going to take a look at slope and equations of lines. And slope, remember, is the ratio of the change of our rise, or y, over the change in our run, or x. When we have two lines that are parallel, then their slopes are the same and they never touch. If we have perpendicular, then their slopes are what we call opposite reciprocals, or if we multiply them, the product is -1. So down here, let's go ahead and fill in same slope for parallel and opposite, or change of sign, and reciprocal, which is just kind of flipping the slope. One thing to keep in mind is vertical and horizontal lines are perpendicular, and we will talk more about that kind of on the next page, but they do form a perpendicular right angle when they meet. Here is our slope formula, so we can do this a couple different ways. We can find the slope using the formula, we can graph it and count our rise over our run, and then we can see whether or not they are parallel, perpendicular, or neither from that point on. So let's use A and B, and we can go ahead and label x1, y1, x2, y2, and we can go ahead and set that up in our equation here to get -6 over -2, or 3. And we'll double check with our graph in just a second. And then our next one is going to be C and D. So again, x1, y1, x2, y2, and take our second y minus our first y on the top, and our second x minus our first x on the bottom, and we get -1/3. So let's go ahead and graph this. 1, 1, and we want to label that A. -1, -5. Let me scroll down here. And that is B. And then we're going to graph 3, 2, and 6, 1. And I should label that C and D, and then there's our A and our B. Sorry, I don't have a straight edge, being a bad example. So from our A and B, we're going up 1, 2, 3, 4, 5, 6 over 2, just like we had here, 6 over 2, which is 3. And then our C to D, down 1 over 3, -1 over 3. So notice that these are opposite reciprocals. If we took 3 times -1/3, we would get -1, and so these are perpendicular. And I don't have them quite, there we go, touching. I should have extended it a little further there. So in this next one, we want to check our slopes to see if we are perpendicular or parallel. So down 2 and over 1, 2, 3, 4, 5, 6. So down 2 over 6, which reduces to -1/3. And then down 2, and then 1, 2, 3, 4, 5, 6. So again, -2 over 6, which is -1/3. So they are the same slope. So parallel, yes. So let's check this next one, or if you want to do that on your own, you can, and then push play to check. So for this first one, I got 4 over 8, or 1/2, but on this second one, I got up 4 over 9, which is not the same. So no, just because they look parallel doesn't always mean that they are. So we do need to make sure we double check their slopes to be sure. So next, we're going to start writing some equations for lines here soon, but first we want to check kind of the equations in some different forms to see if they're parallel or perpendicular. We're very used to slope-intercept form and being able to see that the slope m kind of right in front of the x. When it's in point slope, we can still see that m. It's just that we have our point kind of at the beginning here and end here, kind of separated, but a point, and then this is just the intercept on slope-intercept form. But we can still see our slope, which is super important. So let's jump down here and take a look at our equations of lines. One thing I wanted to kind of go over down here at the bottom is when we get to C, we're going to talk about what vertical and horizontal lines look like, as well as their equations. But for this part, actually we're going to talk about it right now because on A we have one. So I'm going to go ahead and write Vux and Hoy. And that's one of the ways that we can remember that a vertical line has an undefined slope. It's so steep, not even Spider-Man can climb it. And then it has an x equals a number for its equation. So for this example, it's probably like x equals -5, something like that. A Hoy line is obviously going to be the other direction, or horizontal. And it has a 0 slope, and it is a y equals a number for its equation. So as we look at our first example here, this y equals a number, that means it's a Hoy line, or a 0 slope. And then this one has a slope of -4. So those would definitely be neither, because they're not the same and they're not opposite reciprocals. This one has a slope of 5 and this one has a slope of 5. So those would have to be parallel. And then this one is a horizontal and this one is a vertical. And we looked back up here to our notes. We have vertical and horizontal are perpendicular. So those for C would be perpendicular. This next one we have is 1/4 for the slope and 4. Now they're close, they're reciprocals, but they're not opposite. They're not opposite signs, so they are neither. They have to be both opposite and reciprocal. And then this one is a -4.25, and then let's see, what is 4 divided by 17 as a decimal? We want to double check and make sure that's not the same. And nope, it's 0.235. So those are not the same and they are not opposite reciprocals. Actually, I should check and make sure those are not opposite reciprocals. Oh, those are opposite reciprocals. So if I were to flip and put 17 over 4, then I would get 4.25, and they are, so that would be E. So those actually are opposite reciprocals. So double check when we flip it and make sure. And then these we can see are the same. So those would be parallel. All right, so let's go ahead and do a couple of these together, and then I'm going to have you try some. So if I were to write the parallel slope, it would be A over B. And if I wrote a perpendicular slope, I would flip it and change it to be negative. So go ahead and try that next one, or follow along. So -2, exactly the same for parallel. And then we want opposite reciprocal, so change it to positive and then flip it. Whenever it's a whole number, remember it's always over 1. So if you want to try number 3, go ahead. So we should have 2 over 3 and -3 over 2. Now, think back to our Vux and Hoy. This one is a Hoy line, so we would have a slope 0 for parallel, but then remember the perpendicular is always going to be the other one, which in this case this is a Hoy, so it would be a Vux line, so it would be an undefined slope that would be perpendicular to it. And if it were undefined, we would have an undefined for its parallel, and we would have a 0 slope for perpendicular to it. Last thing we're going to do in this lesson is we're going to write an equation. So first we need to know whether or not we're going to be parallel or perpendicular so we can change our slope accordingly. And we need to identify our slope. The slope given is -3. So what would be a slope perpendicular to that? Flip it and change the sign. So we're going to use 1/3, and then we're going to use the coordinates of the point that they give us. So we're going to plug it in, y minus y1 equals m, and then x minus x1. And then we're going to distribute 1/3 x and then negative, and I'm just going to go ahead and take my numerator times this number, which is 4, and divide it by my denominator, which I'm going to leave it since that's not pretty. And then I don't have anything to add or subtract to get over here. Since y is now all alone, we're done. So on this one, we have a slope that's -3, and we want parallel. So we're going to keep that slope the same. And our coordinates, again, are 4 and 0. So it is a y minus 0 equals -3, x minus 4. And we're going to go ahead and distribute. And watch your signs. Negative times a negative should be a +12. And we are done. Nothing to add or subtract to get y alone.